Our next talk is by Nico from TubeMogul, who is going to tell us whether or not you should be using excellent products like Google Cloud Platform or AWS, or whether you should run your own private cloud. So, welcome, Nico.
Thank you, everyone. So my name is Nicolas Brousse. I'm working for TubeMogul. I will explain a little bit what it is in a few seconds so you have some context. As you know, in the past like 8-10 years, there has been a lot of discussion and a lot of industry change about like moving your infrastructure to a public cloud. And we did that. We started to use public cloud in 2008, heavily. But in the past few years, we had an interesting challenge that I will discuss. And we took a different approach and started to move back some of our public cloud workload on a private cloud solution. And I will try to explain some of our challenge and see if it's really worth it or not. Oops. That's bad. All right. That's a demo effect, I guess. All right. Where is it? Sorry for that. I lost the window. There we go. Sorry. So, all right. Where are we? I'll go quickly on this. Software company for digital branding. Basically, we are like, you can see us as a stock exchange, but for advertisement. We are really a software solution that brand can use to manage all their campaign, mostly a video campaign, but we're able to do like any kind of media. We are what we call cross-screen, so we can do like on desktop, mobile, but also TV, connected TV. I think we do some radio in some part, standard display, and we are extending all that heavily. What that mean? That means like last year we handled like over close to 13 trillion ad auction. So it's really a big platform with a lot of volume. We are still a small company, so for us it is a lot of volume. When I joined in 2008, we were like 6 people. We are about like over 600 people now, with an engineering team of like about 50, 200 people, something like that. And we have to scale the system. We did like over 3 billion ad impressions on linear TV. We have a programmatic TV solution. All the bid, all this auction system, like this ad auction, need to happen in less than 50 milliseconds. It's about 80 milliseconds with a network round trip. If we don't answer in this time, in many cases, we'll like time out and not have a loss of a business opportunity. In some other cases, it may even cost us money. And we serve over 5 petabytes of monthly video traffic. It's the part that we serve directly. A lot of the industry is done in a way where most of the assets are not delivered through our platform. People tend to want to deliver their assets themselves. So we are really focused on the trading part. So I represent the operation engineering team. A few years ago, we were just like 4 people. We are about like 15 now. We are made of site reliability engineers, system engineers, and DBAs. Our job, like is to guarantee the smooth day-to-day of the operation. So we handle all the alert, all the monitoring of the infrastructure, and all the standard operation. But we also have to provide like a cost-effective infrastructure and cutting-edge infrastructure. This is to keep us ahead of the industry, to be able to scale the infrastructure in a cost-efficient way and guarantee some performance. We manage over 2,500 servers. I know for some of you it's not that much. For a team like us, it's a lot, and we have to figure out like ways to scale that in an efficient way to scale with the business. We are also technology orders. We have ton of technologies. For a small company that is not that old, but in some extent for a tech startup, it's 8 years is a lot, and we have accumulated a lot of different technologies. That brings its own challenge. Some of them are legitimate, some of them are on their way to get out. It's always a challenge of the last few percent of deprecating an infrastructure. That brings its own set of challenge. We have multiple regions. We have a mix of public cloud infrastructure and on-premises, and we are in the process of deploying 3 new locations. As I speak, we are deploying the US East region. That should be live like in the next coming week. I will get in more detail of that, but same thing, it does bring like some challenge on how to operate that in different environment, different service provider, and different context. What I'm going to talk about is really what we call the bidding layer. It's all this high latency and high volume infrastructure that bring us a lot of challenge. We get a lot of small packets that need to be handled very quickly by our system. This system depends on huge database to make like a targeting decision. So there is our machine learning team and a few other teams that load data to be able to build segment and help the bidder to make their decision and know where to target and how to target customers. All this depends on a huge data set and huge caching system. That's also the part that we are looking at migrating in-house. So, some of the challenge we face with public cloud. High volume traffic and low latencies really make the proximity to our partner matter a lot. We can't guarantee 50 millisecond latencies if we are in US East, but our provider, our partner is in Denver. It's become very hard to do that with network latency and all these things, especially if we don't have control over that. Huge data set. That tend to be like solutions that cost a lot on any public cloud provider. The volume based on API calls or storage size or whatever, the way you take it, it can quickly cost a lot. When you talk about storing like 10 billion objects in one of those solutions, it can be very expensive. Packet per second limitation, that's something that has been a real challenge for us on public cloud. We have high volume and to have like a small footprint and be able to handle efficiently our traffic. We ended up having to extend our footprint because the packet per second limits of some of those virtual instances we are getting on a public cloud provider. Network disruption with no root cause. That has been one of the very frustrating ones, where suddenly you lose like traffic with no like information or analysis, either from your partner or the cloud provider. We saw a few cases, especially in APAC, which is difficult network-wise, to have like just all traffic dropping for like a couple of hours. And we couldn't do anything, and besides like giving phone call and trying to wake up people from our partners or cloud provider. But at the end, we don't know what happened. We don't know if it was like some routing issues. We didn't have visibility on that. Doesn't mean we could have done something, but not having visibility makes it very difficult for the business to know where we are going. So our strategy was to go in-house in 4 locations on 3 continents in less than 6 months using a ready-to-go cloud solution and 2 part-time engineers and celebrate in Vegas. That sounds easy. It's how I sell it. Well, it didn't work. It took like 3 years. and didn't really happen to be a ready-to-go solution. We didn't find one. We ended up on OpenStack and a mix of bare metal, and I will go more in details why. And it was definitely not 2 part-time. It was 3 full-time engineers, and we haven't celebrated yet. So, but the team is still there and excited, and we are very happy on what we are building. It was like definitely a big challenge. So, before getting into detail on what happened and on what we went through, some first challenge we have, especially as a small company, was to explain the value of what we were trying to solve. Is it just a cost problem? How we try to make the TCO analysis on this, and how we justify like this investment on the time, engineering time to do on that. So we had to ask a bunch of questions at some of them, and one of them was like, which infrastructure are we moving? Are we moving all our workload or just a part of it? How do we compare apple to apple? So to have a fair TCO analysis, like if I'm moving like some of my workload, how do I make sure that the cost I'm going to get at the end is going to be the same as what this public cloud provider is actually providing? Do they provide like more services, more options? Do I plan to overcommit? The way I overcommit my own cloud may like totally trick the numbers and make you think like, oh, it's going to be way cheaper. But especially at the time, like 5 years ago, there was a lot of talk, especially when Zynga was making a big move to OpenStack, yeah, I think it was OpenStack already, or CloudStack, whatever. There was discussion with like fairy tales about like 3 or 4 times saving and things like that. So you have to understand what kind of overcommit you plan to do on your hardware. You need to properly cost your engineering resources, the software maintenance, and various support you need on your system. You need to make sure, like, are you making trade-off on the availability of your design? You know what you get with your public cloud provider. You know what they are selling. You know what are their recommendations. Are you getting better cost number because you are like trading off on availability? That's an important question that if you don't ask it yourself, your executive will ask it. Do you plan for a test environment on some RED environment? That's important, and I will get in more detail soon. Are you using actually your cloud provider at its best? It's very important to be honest on this front too. Are you building a public cloud or just optimizing for your workload? In our case, we were not building a public cloud. We were not trying to compete with a public cloud provider. Do you plan for growth, and how does it impact your cost model? Which location are you deploying to? What is the impact on bandwidth and data center cost? If you try to have like a location in Hong Kong, that's not going to be the same cost model as your location in US, things like that. So there is a ton of questions to ask to have like a fair cost analysis. So 3 simple rules. Rule: be fair, challenge your public cloud partner and share your TCO with them. We came up with like cost analysis that we share with our partner, and we challenge them early at the beginning, and even during all the 3 years process. Frequently we are going back to them and saying like, hey, we are building that, so can you help us? Can we solve the problem using your solution? And in some cases, in the problem we were highlighting, they could not help us. In some other cases, they have been able to solve our problem. But still, for this high latency, low latency, high volume infrastructure, we couldn't get the result we expected. Keep it simple. Limit the scope of your cost analysis with a clear and well-known subset. Don't try to do like a cost analysis global with all your location. It will become like very complicated to model for growth, and there will be always like arguments about like, is it fair or not? Is it really, is it a reasonable cost analysis or not? Make clear assumption. You need to be clear on the future list you are trying to build. If you are trying to build a public cloud solution, it's definitely a different requirement than trying to optimize for a specific workload. So what we did, we tried Eucalyptus at the time. We quickly moved on and realized that it was not ready for the show. So we used a vendor to help us move faster and use a cloud stack to make our integration environment. Didn't really work either. So we tried to build ourselves an OpenStack environment. And this took some effort, like about 6 months on its own. There was a first failure. It didn't work either. So do not share your lab. So what happened is that we tried to use our lab environment or system to also be used for development by your developer at the platform layer. This doesn't work because our labs was being destroyed like frequently. There was like the operation development environment and the software team development environment, and we did the mistake of mixing that up just to save like few $1,000. That was not a wise decision. Don't mess up your block storage strategy, no last minute change. At the last minute before going live, we switched from like GlusterFS to Ceph. That was a bad idea. We had no experience with Ceph, and everything blows up, and that was beautiful. Starting a first data center location may require a lot of paperwork time. It took me 7 executives and almost a month to get everyone aligned before we buy our first hardware. Even if everything was approved before, it takes time to educate people and explain what it is, what is a change, and how it works. So you need to plan ahead. And OpenStack is complex. Don't make it more complex. All right, I will go quickly on this one because I think I'm short on time. So what we did after that, we rebuilt our lab on prod environment with a vendor again using OpenStack and Ubuntu. Oops. Didn't work either, so we tried again ourselves with Ubuntu and moved our production to one region. We were more experienced now with OpenStack. We know what we wanted and how to build it. We removed a lot of features that we didn't need. We stopped trying to make the same feature set that some of our public cloud providers, and we really try to focus on what we really care and what we need. And so it's now in production for one of our regions, and we are in the process of doing the other region right now. We decreased our footprint by 40% and our load balancer footprint by 95%. Progressive migration of this workload was not easy. That's something that needs to be planned and really understood. Load balancer and core data service are running currently on bare metal, and we leverage VLANs. We couldn't get the result we wanted with like virtualization, so we went with like some. We basically have a HA proxy and like a bunch of bare metal server. We fully automated our bare metal deployment and OpenStack deployment. Every day in our lab, now we are rebuilding our full cloud to make sure that our provisioning process and configuration are working. This is very important because that's pretty much what helps us solve most of our problem and allow us to move further with this project. And we are deploying 3 new locations right now. We limit the scope to this high latency, high volume and low latency infrastructure. So quickly, lesson learned. OpenStack requires long learning curve and design phase. Account for it in terms of cost, skill set, and time. We were not building a public cloud. Be very clear on your feature set and business case. You don't know your application as well as you think. Be ready to adapt quickly and don't overload the impact of network traffic that switch from private to public cloud. We did that. We saw that a lot. Well, even our software engineer didn't necessarily know the dependencies with some other cloud services. And because you don't see that necessarily on your bill or on your network traffic on your public cloud instance, when you start moving that in-house, you start to see that on your bandwidth, and you start to see like some of those dependencies. And really, you don't know your application as well as you think. We had to deal with a lot of IP contract full, table full with like VMs that were doing like way more traffic than we thought they should be doing, hypervisor being overloaded and stuff like that. So is it worth it? Well, on one region, we can say that we saved, our cost saving was about 30%. And it allows us to reduce our footprint, which allows our team to focus more on like the rest of the infrastructure and scaling our system. We improve visibility on our network traffic, and the full application stack, which help us like troubleshooting and improve performance on our core system. I will say, like lastly, like on the easy to worth it, you need to have a strong technical need to do this move. Cost shouldn't be the only driving factor. Even if we are seeing cost saving, we also did it because of some technical challenge, and I think without those both conditions, you should think twice before moving your workload in-house. And that's it. It's really hybrid. We just took like this part of the system that was causing us challenge. We still keep like a big part of our infrastructure in public cloud, and we have no plan to move it at this time.
Roughly how much?
So it's right now it's just about 25%, but by the end of this quarter, it will be like about like 70% of the infrastructure. But for the rest, we don't plan to move that. We haven't moved like all the like S3. We still plan to use it. We still have like all our machine learning that is planning to be on cloud solution and a lot of other part of the system. Yep.
On the 30% saving, did it actually include engineer time?
Yes.
All right.
So that's one of the big factors that need to be included in your TCO analysis. So what we did after we were settled, we really look at the OPEX, including like engineering time overhead. Yeah. Yeah. Any more questions? All right. Thank you.